Alrighty, welcome everybody to our inaugural Cloud Native Live Fireside Chat. My name is John O'Bacon. I'm the founder and CEO of StateShift. I'm really excited to do this today. We've got some amazing guests on this session. Make sure you are responding in the chat and engaging to make this as fun and as interesting as possible. Now, today we're going to be talking to some friends of ours at Intuit. Now, if you're not familiar with Intuit has been consistent end user members of the CNCF for a long period of time. Probably best known within the CNCF community as the creators of Argo, who donated Argo to the CNCF, and have been very involved in the AI ops and the ML ops communities for quite some time. And what's really interesting here is that Intuit has been on this journey to move all of their products, TurboTax, QuickBooks, etc., to become AI native products. And what we're going to be digging into today is how Intuit has built its platform to build agents at scale, expanding from cloud native into AI native. Okay, and we've got two guests who we're going to be speaking to today. We've got Mukalika Kapas, who's director of product management at Intuit. How are you doing, Mukalika? Doing well? Awesome.
Great. Thank you.
Great to have you. And we've also got Marin Kurian, who's a distinguished engineer at Intuit as well. Great to see you, Marin. How are you doing?
Thank you.
All righty. So why don't we dig right into this? So let's get started. We're talking about AI agents, but how do you define an AI agent? What has been Intuit's experience in this space so far?
Yeah, I can take that. So before we go into agents, I want to quickly call out the difference between a workflow and an agent. So a workflow is when you have predefined set of steps. These steps are executed in a sequence, whereas AI agents can be used for solving open-ended problems, where it's more difficult or even impossible to predict the sequence of steps or the required number of steps even. And you can't hard code a fixed path. So this is where we have seen in examples at Intuit where agents are usually successful. It's about working with unstructured data such as text, images, documents, speech. And going back to how do I define an agent? Agent has key components. Primarily, they have a Gen AI model. It can be a collection or variety of models, large to small. They have tools, which are services or APIs, which provide these agents both the data to load into the context and also the APIs and services to perform actions. The key component in the agent is then an orchestrator, which manages states, leverages memory, past interactions, and reasons with the tools available at the agent's disposal and the LLMs themselves to develop plans and execute so that they can achieve the goals. And finally, these AI agents need to be deployed on a safe and secure runtime and is activated either by a user request or through some other triggers in the environment. So at Intuit, we have been developing agents for the last 2 years or so. Our first generation agents were conversational assistants. So it will do data fetching, answer a question you have. Our current generation of agents is what we are calling done for you experiences. So these agents can act on your behalf, execute tasks when permitted. What is different, I think, in Intuit's journey is that we have enabled all of our engineers to develop agents. So this is part of a transformation for us. So along with the first set of agents, we also launched our first version of the platform, which we call GenOS, short for Generative AI Operating System. So teams can focus on solving customer problems rather than handling the horizontal concerns, which a platform can provide out of the box, like responsible AI, data governance, security, compliance, privacy, and observability. All of these are taken care of by the platform. Now, we didn't start from scratch. Huge thanks to Mukalika and team. All of these were developed on top of Intuit's core development platform, which provided us the paved roads and the runtime guarantees. And that's how we were able to launch this for the velocity we need to scale.
Amazing. Well, thank you. And speaking of Mukalika, who is a legend in this work, I'd like to kind of discuss a little bit about the development journey that you've been on at Intuit. Mukalika, could you share a bit about kind of the technologies you use, the scale, like why did you build it?
Sure. To take you through Intuit's cloud native journey and then AI native journey, in 2011, Intuit began its public cloud journey. They were one of the first companies to move to AWS, mainly doing lift and shift from data center. In 2018, we rolled out an Intuit-wide cloud-native development platform for building and running back-end microservices and front-end micro apps. This gave us the base infrastructure for building and deploying applications and services in a standard, repeatable, and secured way using containers, while sending all the operational data to a central operational data lake. The platform uses many of the CNCF projects, Kubernetes, Argo, Istio, OpenTelemetry for microservices development, as well as we use in-house built technology like App Fabric for micro front-end app. The platform integrates with vendor solutions like, say, GitHub Artifactory, as well as key AWS cloud services. As you know, we open sourced Argo as a part of this journey and hence won the CNCF End User Award twice for our usage as well as contribution. It's no surprise this resulted in a greater than 10x development velocity across Intuit, as well as it enabled rolling out operational excellence standards and best practices that Merin talked about, leading to 5 nines of service availability across the company. Internally, we call this development platform Modern SaaS Platform. To increase our development productivity even further and to enable agents and AI at scale within our product experiences, starting 2022, we went from more cloud native platform to AI native development platform. We not only use AI for, say, code assistant in the inner loop, leading to, say, 40% faster coding on average, but also use AI in the outer loop, say, for auto scaling of our services and agents. We use AI in operations like anomaly detection and observability, and now SRE agents that we'll talk about soon. As Merin said, the platform has standard paved roads for building different software assets like web app paved road, service API paved road, as well as now agent development paved road called GenOS, which provides standardized code templates, CI/CD, out-of-the-box observability, key integration, etc., etc. For example, for agent, it integrates with eval and LLMs. For regular service, say it integrates with just database. We recently open sourced another new project, NumaFlow, to simplify event-driven or async agent and service development, which is also a pretty cool project. Now let's talk about scale. All backend microservices and apps are built and run at scale across 350 plus Kubernetes cluster with greater than million CPU cores. Today, we have around 3,000 plus services, hundreds of apps, tens and thousands of data pipelines, and now 100 plus agents in production on this common platform. We build and run all platform like build platform, AI platform, stream processing platform, batch processing platform, and now agent development platform on this common development platform. To summarize, the value the platform provides is powering more done-for-you product experiences using AI, accelerating development velocity, and finally enabling operational excellence across the company.
Amazing. Amazing. What I love about this is a lot of people are talking about agents and how to build agents online, but you're doing it. Like you're living it, you're breathing it, you're doing it at scale. Merin, I'm curious in your position as a distinguished engineer, how is building an agent any different to building another application or a service on your development platform?
Yeah, good question. So fundamentally, it is an application or a service. It is the extra work that we need to do on top of building the service that makes the agent more effective and better for user experience. So then what is common is all the identity access management, runtime infrastructure, end-to-end tracing, observability, integrations with user experience analytics. All of these are required. They need to be secure, compliant, and private and reliable. All of that remain the same. So the extra work that I talked about are agents need large language models. So now we are getting into the realm of working with AI, where things are mostly non-deterministic. So if depending on the number of LLMs you need to work with and the number of prompts, then you are getting into prompt engineering, optimization, evaluation. Then agents need non-overlapping tools in order to be able to make decisions effectively. So these are natural language description of services optimized for the context of the agent. And you would probably be hearing context engineering a lot these days. So agents also need to optimize the context with which they need to work, so they don't hallucinate, they don't go out of turn, out of sync. So all of these are individual work streams on their own. So this is a lot of the extra work that you need to do on top of developing a regular service and application. So that's just the coding part, right? Now the hardest and most difficult in developing an agent is the evaluation step. So as agents have non-deterministic outcomes, and also you didn't write all the code, right? Nobody actually wrote all the code, so it's harder to debug, test. Even the testing criteria of an agent is extremely subjective, which because you are working with natural language or like English at the time, right? So previously you would have heard, oh, it works for in my machine. Now I'm hearing it works for my data, it works for my questions. So being uh, creating an objective test criteria and doing systematic and structured evaluation, that's another step that you need to do in addition to making your agents work like a regular software. And also, AI solutions are about continuous iterations to solve the problem. So we need the end-to-end data pipeline, moving data from user integrations, experiences, traces, logs back to these eval systems. So we have to have this continuous feedback loop so that the agents can consistently improve over time. So the specific aspect of evaluation and data management is new for a lot of software engineers. So I think that is the huge leap from what is a good software
Mhm.
engineer to a good AI engineer, right? And this is a lot of work, and we know that, right? That is why we build GenOS, right? We want to streamline and help people move fast through this end-to-end life cycle of developing agent, testing them, deploying them, continuously monitoring them, and improving them. So, based on our own learning for the first 2 years, this spring we launched Agent Starter Kit, which further optimizes in the whole CI/CD or the life cycle of managing the development of an agent. So, we came up with the starter code, the CI/CD process, and all the best practices and capabilities baked in. So, you are not going to have to read hundreds of documents, talk to 10 different teams. It's all available for you in a way you can reference and then build your own agent. And we are also, again, given the importance of the space, we are also investing in tutorials, trainings, and whatnot, providing standard pipelines. So, again, our goal is to help teams move faster
Amazing.
through the life cycle so they actually go to production and not get stuck in the POC phase.
Yeah, I love it. And by the way, everybody, just I want to just take a moment before we go on. There's a lot of people talking about how to build agents on LinkedIn, and a lot of people honestly don't know what they're talking about. Whereas Mukalika and Merin are doing it, they're living it, they're breathing it, right? So get your questions in. This is a great opportunity to kind of pick the brains of people who are really doing this at scale in a significant company. So if you've got questions, get them in. It doesn't matter what your question is. It could be a really simple question, it could be a really complex question. Just get them in, so we can tap into their experience. All right, so you mentioned GenOS and you mentioned Agent Starter Kit, but how has this enabled it into it? Like, what would you say are some of the outcomes there?
Yeah, I can start and then Mukli can add more. So remember, Intuit has only about 8,000 engineers, and more than 1,200 of them are now developing agents using GenOS with varying levels of maturity. And so far, we have been able to launch 3,500 plus experiments in production. Our customers have tested and given feedback, and we get on a typical day 450,000 requests on GenOS. And in August alone, the agents on GenOS used 4 trillion tokens. So we have been on this journey. As I was saying, we launched Agent Starter Kit in spring, right before our company-wide hackathon. In that week alone, we got 900 downloads, and 100 plus teams were able to do a demo during the demo day within 5 days, right? So we have significantly brought down the learning curve, the barrier to entry, so people can actually get started. And if you have an idea, then you are able to get go. So, powered by the Agent Starter Kit, QuickBooks launched a series of next generation agents done for experiences this summer. So, we have a whole suite of agents working for customers in our QuickBooks platform. I just wanted to call out 2 of them. So, our accounting agents saves about 12 hours per month for small business in helping them keep their books organized. And the payments agent, which uses a variety of information, which scans emails, images, documents, your whiteboarding, screenshots which you've taken, all of that, and converts them into estimates, which the businesses can then send as invoices, which has helped them get paid 5 days faster with a 10% more likelihood to get paid in full.
Just to add to what Marin said, Intuit is also redefining the mid-market ERP landscape with Intuit Enterprise Suite, a modern AI-native ERP solution with built-in automation for, say, multi-entity management, instant AI-driven insights, and a virtual team of AI agents. What we are hearing already from our customers, 78% of the customers are saying they're getting more time to grow their business. They can focus more on the business than managing their books. 74% of customers are saying they have a better picture of their financial health. So we are already seeing value and ROI out of these agents.
Amazing. Speaking as a QuickBooks user who wants to get paid quicker, I'm all in favor of this. So, we've seen one final question before we get to some of the viewer questions. We've seen the rise of agents within the infrastructure space with the likes of, SRE agents. But how are you thinking about incorporating agents in the platform engineering side of things?
So like everybody else, we first rolled out multiple AI-powered code assistants for code generation, test generation in the inner loop of development. But now agentic development is changing the whole product development lifecycle. Today, over 30% of developers' time is spent in outer loop troubleshooting issues, managing infrastructure, managing incidents. Despite progress, change-induced incidents still remain high, even within Intuit, and recovery times are inconsistent. So last few years, we focused on customer-centric observability using golden signals, real user monitoring, and distributed tracing on top of our central operational data lake. Because you have to remember, agents first need clean data to work, okay? Just like any other AI. We started with implementing near real-time anomaly detection on top of that data for observability and progressive delivery first, before going into the agentic space. Now that we have a matured operational data and data pipelines and end-to-end observability, we first rolled out Incident Recovery Agent, which during an incident traverses our asset dependencies, because incidents are not just caused by one software asset. It can be caused by a downstream asset impacting multiple assets. And then it triages logs, metrics, traces, change events. Change events are very important to identify what's the root cause of the incident, step by step with developer feedback loop to enable faster incident recovery. Today, the agent is already being able to find the root cause of more than 50% of our incidents. As Marin said, we constantly do the eval of the agent with real incident data. Okay. Other areas where we are experimenting with agents in the platform are agents doing tasks asynchronously, trying to remediate any security defects that our security team opens across the company, or upgrade, say, tech debt, like upgrading Java version, asynchronous agents going to your repo, finding dependencies, and doing the upgrade. We are doing on-call alert triaging. On-call engineers get lots of alerts, and to triage and figure out which one to take action and which one not to. Build and deployment failure. Our biggest developer question in support Slacks is why my build failed and why my deployment is giving crash loop back off, okay? Like triaging and insights. And then developer support. We are trying to answer majority of our developers' questions with conversational agents before sending them to the second tier of support.
Yeah, amazing. So we got a question here from somebody who was a mystery. They did not add their name, so I'm going to assume it's obviously Brad Pitt, who said, how can I add AI agents into Kubernetes clusters to help me fix issues?
So We have platform engineers who maintain the Kubernetes clusters, and obviously then the service developers who use the Kubernetes cluster to build their own agents or their own services. So our platform engineering team are experimenting with agents first to triage issues, because we need to be 100% accurate in triaging issues with human in the loop before making deterministic production changes in the Kubernetes clusters.
Amazing. And then we got a question here from Larry. I love this question. He says, I'd love to hear about the economics of the platform. 1 million plus cores is huge, literally and figuratively. The ROI must be there to make it viable. For companies thinking about adopting agents, how do you balance the investment versus the results?
I'll take a first shot and then Maren can add. So just to clarify, 1 million plus cores was the overall platform on which we run services, APIs, data pipelines, web apps, and agents. We are not yet running 1 million plus cores with agents because every agent that we are running in production, the first thing we are measuring is the accuracy of the answers that they're giving to the customers. And we are experimenting, but we are being very careful to run them in production with especially giving answers to our customers. ROI, we already mentioned like how our customers are getting money back faster, how they're saying they're getting time back to invest in their business. Maren, do you want to add anything else?
Yeah, just exactly what Mukulika said, right? We encourage a lot of experimentation. Doesn't mean that every experiment goes to scale to our entire customer base. So we are always ruthlessly prioritizing what must get the investment, which provides the most benefit for our customers.
Love it.
And
Progress over perfection.
for example, our SRE agent, we are tracking that if it takes 20 minutes to find a root cause of an issue for a human, less than 5 minutes for an agent. And so far, for 50% of the cases, the agent is finding within less than 5 minutes.
Amazing, amazing. And then I think this is probably going to be our final question because we're running out of time here. This is from Jan Harvey. I hope I'm pronouncing your name correctly. What are the first practical steps an individual developer can take to start building and deploying AI agents on Kubernetes, especially if they're new to cloud native tools and orchestration?
Maren, you want to take it?
Yeah, I'm assuming this is not about building infrastructure agents, but generally agents, but on top of Kubernetes. It is like how you would develop any agent. Don't worry about infrastructure and cloud first. Figure out how to build an agent effectively in your machine, and then slowly build up on whatever infrastructure you have available in your organization, right? And I think the fundamental difference, like I called out, is that this is a lot of software engineers' first experience working with AI. So that is the place where you need to upskill yourself and invest more. The infrastructure will follow, the tooling will follow. If last 2 years is any indication, things will be better, the tooling will get better, there will be a lot more streamlining. But the skill that you need to invest in yourself is how to leverage AI effectively. That you have to do on your own.
Amazing. Well, Mukulika, Maren, thank you so much for joining us today. This was the inaugural Cloud Native Live Fireside Chat. Thank you for joining us today. Everybody, go and check out the Intuit open source page on LinkedIn. You can see the link right there on the screen, and we'll hopefully have some people in the background maybe pop a link into the chat. And then also, there's going to be more of these sessions where you can learn from people who are doing amazing work in Cloud Native and beyond. So be sure to watch this session. You can be able to check out the recording on LinkedIn and YouTube, and then stay tuned for future sessions as well. So thanks, everyone. Have a great week, and we'll see you on the next one.